All right, so, well, good morning, good afternoon, good evening, who knows, everyone. I'm really happy to be here today. So I'm Patrick Plichart. I'm co-founder and solution architect at Open Assessment Technologies. And today I'm joined by Jean-Philippe Rivière, founder of Wiquid. And we are really excited to introduce you to the concept of portable custom interactions, a slightly more technical topic, but we have prepared some demonstration for you to make sure we convey the right messages here. So I wanted to start this presentation with some pictures here. Basically, so OAT is helping a lot of countries in their digital transformation of their assessments. And what we have been witnessing quite often is obviously there is a tradition of using paper for national exams or diagnostic assessments. And the trend is obviously, and it's natural, right, is to start by thinking that going digital is basically taking all the paper exams and flipping it upside down, sticking it on the screen. And there you go, you have your digital assessment, right? And it's okay, right? It's a start. But obviously it's a bit narrow, right? You still limit yourself with what was possible on the paper for assessment. And obviously nowadays with computers, with web-based application, you can really go beyond what is possible on the paper, and you can leverage more interesting data than just a final response, a final choice to a question. You can really look at how the candidate, the student, the kid behave during the assessment, and focus a little bit more on detecting the exact weaknesses and where you can improve, right? Is learning journey. So it's a bit more opportunistic, right? This presentation, we are looking at what the technology is capable of, and we are offering that to the assessment world. But you will all agree, especially from the learning ecosystem, in the learning ecosystem software, there are plenty of applications there already available that are very rich, where learners can discover artifacts, can see how those artifacts behave, can really learn, right, through those web-based application. So they are very rich, very interactive, with a strong focus on learning, discovering, trying, etc. And while in the assessment area, we are still a bit limited indeed to simple choice question at the end of the day. And here, obviously, the opportunity is to start leveraging all those learning web-based applications. And you might think, okay, but it seems quite difficult also from a technological standpoint, right, to start taking all of those cool web-based applications and embed that into an assessment platform. I mean, it means integration, it means effort. What does it mean exactly, right? And it might seem expensive, right, to start leveraging all those applications into an assessment platform to deliver this to students in the context of assessment this time. Why not just in the context of strict educational content, right? Well, actually, it's not that difficult. It's not expensive. And this is where this concept of portable custom interactions kicks in. So today, you have a lot of those educational web apps that are open source, right? So that means they are free to be used, even to be modified very often, etc. Like here, so here I have some in the illustrations. I have Geogebra in top left, maybe you know it. There's Blockly, it's a programming tool where kids can learn to program, so they can run their little program, etc. We have also a lot of science-based web applications, implementing physics, etc. Sometimes gamification of math. So there are plenty of those web-based apps, and a lot of them are also open source, so free. There are also open source assessment platform already out there in the market, and Tao is one, right? It's actually the leading one. And in order to be able to embed all those interactive web-based application into an assessment platform, you can use standards, and you can use this concept of portable custom interaction. I will describe a little bit how it works exactly all together. But that's the idea, basically, is that you can go beyond traditional interaction, beyond multiple choice, right? And use any kind of rich interactions within your assessment using PCI. So how does it work? Just from a high-level standpoint. Basically, a PCI, so this is a standard from one EdTech, right, formerly known as IMS, right? So it's part of QTI standard, so it's a standard that describes assessment content. So, which basically means also that any content, any assessment, any test described in QTI is interoperable. So that means it can be exported in and out between systems of assessments, right? And PCI is part of that, right? So that means that any assessment that will contain a PCI will also be interoperable, can be moved from one system, assessment system, to the other, right? So how it works is basically a technical interface that basically states that, okay, whatever the interaction, whatever the content there, the rich content, right? Whatever, a PCI needs to submit at some point data, like process data, right? But it's some sort of black box, this process data, right, for analysis, and a final score, right? But within the PCI, it can be anything. It can be a video game. It can be anything that is doable nowadays with computers, right? So what we do usually to be able to leverage that opportunity is that we can wrap any web-based application, preferably open source, as a PCI to make sure that this web-based application, Rich, can submit this kind of data to our system using this PCI interface. And once we have just wrapped this web-based application, then you can embed it into assessments, and it can be run in any QTI, PCI compliant test runner like ours that is called Tao Advanced. And there you go, you can administer assessments, including rich interactions, generating data that is not limited to a final response, including process data, behavior, right? So particularly interesting to for analysis to determine also the learning behavior, etc. Right? And yeah, so that is PCI, right, in a nutshell. And we thought that we will demonstrate a little bit this concept with just a few examples running in the Tao platform. And for this, I will basically give the token now to Jean-Philippe Rivière, who will make the demonstration. So please, Jean-Philippe.
Hello, I'm Jean-Philippe Rivière. I'm based in Toulouse, France. And today I'm going to show you a little bit of my work. And Patrick, I will take... Can you? Yes, thank you. Let's share. You should see now my Tao platform for the demo. But first of all, I wanted to say something about the PCI. PCI, it's true that I am a PCI developer. I developed a lot of PCI for the French Ministry of Education. And it could be simple to do, it could be complex. I'm going to show you today the Geogebra PCI. That was not a simple work because at the origin, Geogebra was not designed to be a PCI. So I had to create with the Geogebra team as a Geogebra developer. I had to modify a little bit their code to adapt and to find solutions that were not so obvious. So technically, this work was important. And it is true, as I said, as Patrick said, that a PCI could be very, very simple. In this case, we are talking about implemented a whole application, and that is quite complex. So, but just to be clear, this product is completely free. It's under Geogebra license, so you can download it, put it in Tau, and use it as you want. What is the idea of a Geogebra PCI? When you have to organize an assessment, you can use simply this PCI as a complementary tool. I show you, for example, here, I can describe an activity and ask to do some task to the student. And below there is the full Geogebra application that is available with all the menu, all the capacity you can have with Geogebra. And it is a neutral environment for Geogebra. And the student just have to use it. And we can collect, as Patrick said, we can collect some all information we want from this activity, and also track all the action that was done by the student. The idea is also to have the possibility to use the fantastic Geogebra library. And here I just have a little problem here. Sorry. If you are going to geogebra.org, you can browse the library, and the library is completely huge. It has many items already done. It is not sometimes it's really items, sometimes it's a part of a lesson, an illustration, a way to show how to do something. So it is really rich. And it is very easy to import this element in the Tau platform and in the PCI. I show you, but I just have to. Can you see my screen? Yes, I think so. Patrick, yes, I have to show you this. This is the most important. In the URL, you have a code, and the code correspond to the activity. Here, for example, we can let's have a look here. For example, at this application here, and we have this code. We can grab this code and go to the Tau platform. Here we are, and in the Tau platform, we can just paste the element here, and you see there is a preview, and we can open the project and immediately use it to build some questions, and that is very efficient. And it means that you can inject more than 1 million of items in the Tau platform. That is very rich, very efficient. So I was talking about this first step. We don't say for the moment. The first step was to use Geogebra as a complementary tool in an assessment. As a neutral tool, let's say, but it could be also a part. It could be also a part of the instruction. I mean that you could present to the student in some ways. I've chosen here a spreadsheet and a chart, but there is many configuration. If you, I don't know what is your level of knowledge in Geogebra, but you have many configuration. I can take some seconds to show you how it works. And so it is a part of the presentation. It means that you are building your question your item, showing this information and using to create the question. Another way to see the GeoGebra part in an item could be, for example, to show, for example, this item looks like it's quite complex. It is showing many action, many parameters, and it could be a part, not of the question, let's say, but a part of the answer. I mean that the student will have to manipulate, to explore, to click, to interact with the item to find the solution and to answer, of course. Next. So you understand that GeoGebra can be it's so complex and so rich that it is a kind of subsystem of generating items, like a special framework to generate item in Tao. Here, for example, I show a way to create this kind of representation, graphical representation, and I'm showing a process and illustrating how I followed the process. And the real instruction here are showing that there is another process to redo with GeoGebra. You must have in mind that GeoGebra is very used in French college, in French schools for 11 years old, starting from 11 years old. So the learning curve of GeoGebra is now, let's say that they are already the knowledge to use GeoGebra, and it is really relevant to propose and to check how they can master this tool in this kind of context. Voilà. And you just noticed also one thing. It is that a PCI must be an element that at is own logic, and it's an autonomous module. Autonomous modules means that you can have many instances in the same item. So it could be quite a complex item, and you can add many GeoGebra in the same place.
5 minutes to go.
5 minutes, yes. You could have also GeoGebra as a complex stimulus analysis. You see that you can propose element to interact to, and say, let's say, can you do how can you realize an item like that? And you could ask, you can mix that with common interaction, of course, and ask the student to write a scenery to do this kind of work. And here, it's very important to have in mind that it's so powerful and it is so open that GeoGebra, of course, can be used not only for math, but for a different kind of activity and for different kind of thematics. It's really interesting to learn how you can use it and to see if in the GeoGebra library there is not an item that could help you to assess, to help you to teach the content. Another thing is it is very impressive to see that how GeoGebra can propose a really different solution. For example, here you have a whole environment to make a design. Here you can use a ruler here and create some lines, of course, with the pen. And I have no time to do a demo like this, but it is quite rich. You have many possibilities. You can combine that with classic mathematical tools with different forms and figures. And you can also integrate really, really complex element. For example, you can use it as a mind mapper, and you can put images, sound, and many, many things. So it is really a creative tool, open creative tool that not only mathematicians can use. And yes, it's quite interesting in this. What else? There are so many things to show. Let's say that yes. So if you understand well, a PCI is a kind of an element in a Lego, and a question could be composed with many PCIs. So if you just check, for example, here I have few PCIs that I have already done, and all PCIs can be combined with or common interaction or different PCI. Yeah. Just to finish the presentation, I have maybe 1 minute. No, something. Yes. Geogebra has also a very powerful tool that for me it's quite important. For example, you have the zooming capacity, and you can put it right everything in a bigger screen. So it could be very helpful for in some cases. Of course, you have internalization. So it means that all the translation are already implemented. You have the dimension of GeoGebra. If you are using, for example, tablets or different kind of screens, you can adapt all your settings here. And you have a very important element that is the construction protocol. The construction protocol is following each step realized by the student, and it's a kind of super report to analyze how the student has interacted with the application. I think that, yes, I didn't talk about the scoring system. The scoring system is could be all automatic, or you can gather some information. You will choose some information and build your item respecting some rules, or you can also take the whole representation of the application. I mean that if you ask a student to realize an application, a graph or some formulas in GeoGebra, you can grab it at a B64 string. Yes, that's it. I think I tried to show you how GeoGebra PCI is rich, and it is quite expected in the little world of the digital assessment. Thank you.